Okay, welcome to part 4 of our lecture video series from Wednesday, March 1st, where we learned the rules and process for how to draw Lewis dot structures for simple covalent compounds. So I'm going to demonstrate this to you by going through the rules and also using water as an example. So I'm going to be showing you the rules and then applying it in the example looking at water. So the first rule is to begin by counting the total number of valence electrons that are available to be used in our Lewis structure in the compound or molecule. So if we are looking at water, we know that oxygen has a valence configuration of 2s2, 2p4. So this has 6 valence electrons. And then hydrogen, of course, is just 1s1. And then remember, I've got 2 of these, so I'm going to double the amount of valence electrons contributed by my hydrogen, so that's in total 2 valence electrons. Apologies, apparently everybody is emailing me at the moment. All right, so if I were to take the total valence electrons from my oxygen and the total valence electrons contributed from each of my 2 hydrogens, this would give me 8 valence electrons that I can use to make my compound. The next step is to place elements symmetrically around a central atom, where the central atom is typically the atom written first, unless that thing is hydrogen. So if hydrogen's written first, like it is here in our H2O example, then we would use oxygen as our central and not the hydrogens. And as a general rule of thumb, carbon is almost always central. Almost. And if there's no central atom, like if it seems like there's an even number and you can't decide which one goes in the middle, then use your intuition. Like, for example, if we see something like C2H2, that's 2 carbons and 2 hydrogens, I would probably use both of my carbons as, quote, central, and then figure out what to do from there. So in our example with water, I've got to place my oxygen element symbol, and then symmetrically around that, my hydrogens, like so. That is step 2. Step 3, connect our outer elements to our central atom using a single covalent bond, where remember, a line, which is our single covalent bond, represents a shared electron pair or a bonding pair, BP. So in our example with water, I've got H, I've got O, I've got H. I am going to connect each of my hydrogens to the central atom. And anytime you do something like this, you got to remember that since we are using up electrons, right, each of these lines represents 2 electrons, I need to kind of keep tally of how many electrons I have left. So I started with 8 valence electrons, and now I've drawn 2 bonding pairs as 2 single bonds. So in doing so, I have used up 2 in this bond and 2 in this, which is 4. Which means that as of this point, I still have 4 electrons left. So I am not done building my compound, but so far I've got a good start. So when you're drawing these Lewis dot structures, you need to use all of your available valence electrons, and you cannot use any more than that. You're on a budget, so to speak. Okay, step 4 is to fill in the octet of your outermost elements with your remaining valence electrons. And you're going to start with your most electronegative outer atoms. So in the case of water, we would look at our outermost elements here. So we've got outer hydrogens that have been connected via oxygen to oxygen via a single covalent bond. And I know that I have 4 electrons left. However, I also have to pay attention to your octets and duets. Because if I were to look at my hydrogen atom on the left, in forming this single covalent bond with oxygen, it now has 2, albeit shared, but 2 valence electrons surrounding it, meaning it has met its duet. I cannot add any more electrons into that orbital that hydrogen is contributing to this compound. And same deal for my hydrogen on the right. I cannot place any more electrons around these hydrogen atoms because their valence orbital, that 1s orbital, is totally full from sharing with the oxygen. So for me, I can't add any of my valence electrons here, not applicable to my outer elements, because I've already met the duet rule for hydrogen. So I can't overburden them with electrons. Which means we have to move on to step 5, which is to add any remaining electrons to the central atom. And again, you cannot disobey your octet or duet rule. So let's look at our hydrogens and our oxygens and our Lewis dot. So far we've got this. And remember from our tally up here, we've got 4 electrons left. And we want to make sure that we're not going to overburden the oxygen by adding those 4 electrons. So if I were to look at my oxygen atom, let's just count how many valence electrons it now has as a result of sharing with these hydrogen atoms. So each of these lines is a bonding pair, so that's 2, 4. So it looks like it can take in 4 more electrons to achieve octet, which is great because I've got 4 electrons left. So let's add those in. All right, so 4 left, 1, 2, placing them opposite, and then doubling up, 3, 4. And then again, we are always going to check our octets or our duets. So hydrogen on the left, 2 electrons shared, met duet. Hydrogen on the right, 2 electrons shared, met duet. So that's stable. Oxygen in the middle, we have 2 bonding pairs, so it's 2 4 electrons that are shared, and 2 lone pairs, 6 8. That meets octet. So 2 bonding pairs and 2 lone pairs means 8 valence electrons on oxygen. And then 2 bonding pairs on each hydrogen means that we've got duet met for hydrogen. And then let's just do one final tally or count of our valence electrons to make sure that we have used no more or no less than we were allowed to. So we were able to use 8. So if I were to not scroll past the notes and actually go count, I would see that we've got 2, 4, 6, 8. So I've used up all of my 8 electrons, and I've satisfied everybody's octet. So this would be the Lewis dot structure for water, drawn like so. 2 bonding pairs, 2 lone pairs. Now, not every element or, compound is as simple as water. So by the time you're at step 5, you have drawn, if there's some kind of option here, what's known as a skeletal structure, where you have used up all of your valence electrons, and you know for certain that your outermost atoms have full octets. Now for compounds that are a little bit more complex than water, we might have to do a little bit more. So on Friday, we're going to continue this process or procedure. So we're going to start over from the very beginning with some new element, and we're going to look at what might have to follow if our skeletal structure is not our actual Lewis dot structure. Because here, we've used up all our valence electrons. We know that the duets on the outermost are full, but since we also have everybody with satisfied octet, then this is a valid Lewis dot structure. So on Friday, like I said, we'll practice with more complex covalent compounds. And that wraps it up for our topic list for today, Wednesday, March 1st.